Okay, let's go. In the world of Dota 2, there are two parties, the Radiant and the Dire. The Dota 2 Senate consists of senators coming from two parties. Now the Senate wants to make a decision about a change in the Dota 2 game. The voting for this change is a round-based procedure. In each round, each senator can exercise one of two rights. Ban a senator's right. A senator can make another senator lose all his rights this and the following round, announce the victory. This senator found the senators who still have rights to vote for the same party can announce the victory. What? Not quite sure. Okay, let me read this again, but a little bit slower. And the Dota 2 part is messing me up a little bit because that's nothing to do with the Dota, it seems like, other than the Radiant and the Dire thing. But okay. So basically, the Senate has two parties, and so this feels like a game theory thing where each round a senator can basically remove a senator on the other, well, presumably the other side. If this senator found the senator who still have rights to vote. Okay, so and if there are only people from one party left, then they can vote. Oh, and there's an okay. I mean, so that part makes sense, but I guess they don't alternate, so that makes give me a sure. Audio, if they're antennas, okay. Okay, so Senate is Senate is a string that basically is either R or D, and okay. The round base starts with the first senator. The first will last until end of the voting. Okay, I mean, suppose every senator is smart enough, so they don't actually tell you the strategy that the senator is like the optimal game theory strategy. I think in this case, what you want to do, if this was an interview question, it's probably a really annoying one because it has a little bit of a gotcha and a little bit of whatever. And I think for me, the naive but intuition about this problem is that you just use the greedy strategy, which is if you're up, you're just gonna vote for the closest person who is on the next, or the person on the other team that is going to be up next, right? Because if you could choose between if I'm a senator and I could choose between two senators on the other side. I mean, so clearly you want to ban someone on the other side, and if you have to choose between two of them, you should always choose the person who started earlier, because then like it kind of pushes their team's action, if you will, later as soon as possible. So I think that should be the strategy. The reason why I don't like this as an interview question is because if we greedy solution. I mean, well, there's game theory, which is always a little tricky in general, but greedy solutions are also like just really hard to prove. You have like, in theory, you should prove it correct, and sometimes greedy solutions are, I feel, has a lot of intuition based on it, but unless like you're very mathematical and you really have to prove it correct, and the proofs are not always obvious or trivial to do to convince yourself. It's almost like try to find a counterexample and can't. At least for me, I'm not that good, but in this case, I think that's my that's how I'm going to approach it. Yeah, and then okay, so there are up to 10,000 characters in a string. So what? So I think that's about right. So I think the question is, well, now how do I code it, right? Uh, hmm. So the other question is, Okay, so I mean, I think so. So I think we talked about that. What the optimal. When I say optimal solution, I mean an optimal strategy for the parties to play. But now you have to code it, right? And I think the naive thing you can do, given what I said, is some kind of n square algorithm by having like, okay, for each in the index, um, each ive in the index, go to the next, which is another iteration, go to the next j such that j is on the other team, right? So that's n squared, but as you can see, given that uh, it could go up to 10,000, I think for anything higher than 1,000, I would hesitate to use n square algorithms unless you're doing something like really obvious and really minimal. And even then, like, I don't know, performance is going to be an issue. So I would look for n solution or n log n solution. In theory, I mean, there's probably an n log n solution somewhere that you can kind of, have because you could probably find some precessor successor precessor successor data structure on some kind of tree that will allow you to have a log n, find next log n. But I think you could actually, because this is only this only has two kind of two type of elements. I think you could probably even do smarter than that by having n. You probably get an O of n solution just by kind of thinking the problem in a different way. Now that you have that type of solution, so what happens is, um, because I think what you should do is kind of what you're really keeping track of is the runs like or the ones or the streaks that you're keeping track of, right? So basically, if you have like for example, I guess I'll try to visualize this a little bit better. For example, if you have like RD, RD, at this point, at this at this point, the only thing that is in the state is just the number of R's that are beforehand, and then that incremental decrements by one. So I think what I'm going to do is okay, and I think we just have to keep track of like the number of yeah. I think you all you need is an integer or something like that to kind of keep track of kind of how many remaining bands there are of the other side, right? Uh, and I, and I think you can actually do this with just an integer. You don't even need a variable. Is that true? Huh. But hmm. I'm trying to think about all the edge cases and whether I'm actually right about this. But okay, I guess I could code out a little bit first. So oh, this is this Python. So delta equals 0. For senator and senate. Uh, all right, let's print senator first. I always forget the behavior of strings and characters because, to be frank, that doesn't really come up that much that you need to parse character by character in the real world. So when I do Python, I don't know. Maybe that's just an excuse I forget. I just want to make sure that I'm right, because otherwise you end up spending a lot of time, on. I like to kind of make sure that my assumptions are correct, and if my assumptions are wrong here, then like I spend a lot of time doing something that I don't do otherwise. Okay, but it seems like that should be okay. So it goes in R and a D. So so I think what I do now is if senator is equal to R, then I do delta plus 1, else. I'm trying to think why, like, I think the way I've now phrased it, I'm trying to figure out why, like, how is this different than just, I mean, as you can tell from here, how is this different than just the number? Man, this is like a really roundabout way to kind of like just be like counting the votes, because uh, I think like for all the talking I have, all the thinking, I think this just turns out to be just like count the number of R's and the number of D's, and I think it's kind of um, and I gotta admit this problem got me a little good in the sense that the way I'm looking at this problem now or thinking about this problem is just simple voting, right? Because because right now, because in this part, the ban one senator's right, it just turns out to be that if you ban one senator's right, and your only right is to make a count, that means basically you just cancel each other out, right? So, so, so I guess, so I guess ignore all the things I said about game theory. Basically, this is just a really roundabout way of asking who has more votes, the Radiant or the Dire team in a very not subtle R&D, and yeah, I mean I think that's it, and it kind of I feel like I've been had a little bit. Still, so I think the thing I'm trying to see now is what happens if there's a tide or something, right? Because okay, I'll just finish writing this out. Oh, is it Radiant? Oh, return die. Okay. I mean, I think so. This is roughly right, but I think I'm just trying to figure out. Sorry. I'm just trying to figure out like what happens when, um, well, they're tied essentially. But I guess this happens here. Oh, okay. So I think I messed up something here in how I interpret it. Because this is a round-based thing, so the end center. Is this simultaneous? Maybe I just misread something. Let me read it again. It is a way. End center. Okay. Okay. Mm. Okay, so what I said about canceling off is actually not true because there are multiple rounds. I actually, yeah, this is a very confusing problem to read, but okay, so this is not true. But still, yeah, the greedy solution I think is still true. It's just that we have to do something a little bit fancier. Uh, okay, let me try to see if I could think about this from scratch a little bit first. Um, so after the first round, but is that true? Hmm. After the first round, the so I think actually the multi-round, maybe this is just a silly gotcha, but because after the first round, if I feel like the team that had more, no, that's not true. Because so what I'm thinking now is that let's say there's something like a huge one. You have like let's just say 5, and you have 2 Ds, or let's say even 5 Ds, right? So in this case, after round 1, obviously these were banned, but then let's say you want to have 8 Ds, these 5 guys or gals will be on the dire side would be banned, and the 3 Ds would these 3 will ban. So it's not quite the same. Okay. So I think so I think this part of the code is still valid, but we have to kind of factor that in for multiple rounds. Um, hmm. uh, yeah, I think so. I think the observation about the runs still makes sense. Um, and I'm just trying to think if I need to kind of store the entire center to kind of take that into consideration. But I guess that's the easiest way. Um, okay. Uh, yeah, let me just do it in C just so it'll be slightly faster, maybe. Uh, mm, wait, does that work? Oh, oh my god, switching back and forth. Okay. Uh, uh, the reason why I'm testing is because I just want to make sure that like some of these functions are in like standard IO.h or something like that, and I don't know if how the Leetcode kind of take take consideration to like that to import the library or something like that. So that's what I'm testing as well. Okay, cool. Um, yep, how many pass do you have to do at most? I think so. What we said about the algorithm earlier, it's still true that so in this case we would get an O of n time for one pass. So at very least, or sorry, so yeah. So you're not doing anything n squared or even n log n, and the n log n solution it takes a lot more effort anyway. So I think that's what I'm optimizing for. Um, but my question now is try to figure out well, like what is the worst case scenario of this code, right? Well, if the inner loop for rounds is n, then how many outer loops is there, right? And I think it is a tricky question. I think at worst there should be. I mean, I think it actually does better than this in practice. But the worst case is that after one round of voting, have to. I mean, it's actually better than this for sure because then the early termination would win. But I think after one round of voting, what happens is at, at least half of them is eliminated from the Senate. And if that's the case, then you only have log n. So at worst, it should be n log n. And 10,000 times, what is it? 15 should be okay, right? Whatever it is. Okay, so I'm just gonna do that here, and I'm gonna do. Yeah, okay. I mean, this is maybe not. Well, I'm going to do what I can do with the most naive things first, and then we'll see if I need to optimize it. Oh my god, these auto brackets, I'm too used to writing my own brackets. Okay. So each of these simulates one round of voting. If, oh man, I'm in C now. If this is an R, how do I want to write this? So basically, you have four scenarios, right? Where because before we didn't, if I had assumed that was only one round, so then you could just eliminate. Because if you have just one round, then you don't have to store the states. But now we want to actually, ban a senator. So okay. So if delta is basically this means oh my god. else. So that means that it adds it to the band queue, if you will. Wait, is that true? Can I do this? Well, you can, but you just have to post process it. Because what I was thinking about the case is, you have a case like, uh, right? So you would have the streak of one, so these three gets banned, and then you increase the delta, but then you have to basically run the delta back to zero by banning all from the beginning. Okay, well, we'll see if it's performant. Still fused. I mean, it's still n log n, but maybe there could be some micro optimization, but they're linear time optimizations that I don't know if I need to make yet. So yeah, add to the run. Otherwise, we just set it to 0. So we just zero it out, and I know this manipulates the input, but it should be okay. Else if so you keep on that one. Otherwise, this guy got destroyed. Oh no. Sorry, Senator. Okay, so at the end of this, yeah. Now we go back to the beginning to pick people who would get eliminated on the other side. Also, this is one of those things where you really want to be careful. Otherwise, it's easy to make a loop error. Yeah, this is not right. Yeah, okay. So if delta is greater than 0, that means they're more R's than D, so you need to ban these. Oh, what am I doing? And okay. I guess I should run it down. Okay, and then now you just do the same for R's. And this should end as we get to the end, or delta is equal to 0. Okay, and that's the end of a round. I think now we just, for the end of each round, though, I mean, I do it at the end of this round. You can actually do it at the beginning. It doesn't. Don't think it really matters. I'm trying to think about the edge case where yeah, I mean, I think if everyone is already banned, it doesn't matter when you check it. Everyone on the other team, that is. So I'm just going to check it at the end of the round. Yeah, okay, I'm doing something wonky here. Okay, fine. Do I need to do a new loop? Can I do the previous loop? I mean, I think in theory you could add more logic to this loop to check, but I think for clarity purposes, I'll just put it here. I could probably clean this up, but oh no, what did I do? Close the window by accident. Close a window by accident. I guess I don't need done in this case, but more that I guess I could have used whatever. So done is one. Oh. Then now I could return, I guess, actually. Because one team from one side. Oh, wait, no. No, what? Mask is not equal to do it. Return tire. Okay. So this should be okay, but I think there's a lot of it is a bit of a mess, to be honest. It is a big function, fully line function. You shouldn't follow, but there's just a lot of potential for typos and a little bit of code repetition, and but everything in here should be everything inside the while loop is linear, at least, and everything outside and the done should, in theory, terminate in log n times. It's just I don't know. There's just a lot of potential for kind of typos, and that kind of scares me a bit. So yeah, but let's run the code again and see what happens. Can now reach the end of the non-words thing. And also this, I guess I don't really need to run bit because I don't actually use it. For tweak. What happened to his mask is 0? That means nothing left. That's weird. Would be weird. Okay, so heap overflow. Heap overflow. What did I do? What did I do? I don't allocate any new memory with other than like here within the I think I change this. Man, that's what I get for trying to be too clever. But alright, let's just let's take out the while loop for now, and then let's see what happens after one iteration. It'll complain about no return value though. Yeah. Okay. Return. Yeah. Well, heap buffer overflow. Huh. Actually, don't think I've seen this error before. Oops. So I'm gonna just but can't click on it, but I could click on it but not copy and paste it. That is actually kind of unfortunate. Okay, fine. Just gonna Google this real quick, to be honest. Not sure what this error is. Did I choose the wrong language? Nope. Okay. So it sounds like that is weird. I mean, is it because I'm setting stuff to 0? Let's see. Huh. Well, this is a tricky one. Man, I have no idea what this means, to be honest. Huh. I mean, it seems like there's stuff where like I'm running into memory access issues. So actually, these may look suspect. No, I is still less than. Did I change it in any way? I guess this is not necessary per se. So that, am I doing some weird thing with I? Oh, yeah, okay. So maybe I was just, maybe those were supposed to be ands, and I'm just being, and you know what they say about premature optimization, I guess. You're dumb for trying to think you could do better. Okay, so I mean, these passed the first 2 tests. Still not confident about it. So let's see, what's the difference between this? So now I'm going to try to because I'm not confident about it. I'm going to just work out what that should give and what it actually gives, right? So now the first R will bend the first D, and then D will bend the first R, and then the first R will bend D. So the radiant side should win on this. Come on, baby. Oh, and that tells you to expect it. So actually, I don't know how I feel about that actually, but because that's not one of the example tests. But then in theory, I could also just do what I said earlier, and then in theory the D's should win. I also agree that the Dire should win, but my code is giving me Radiant. Okay. Oh, I guess I don't need this anymore. Damn it, campaign. Okay. Okay, so we do find a case where it's not working, which is good. I mean, the best time to check to see if they checked in is before you submit it. You don't want to submit it and get a wrong answer. But okay, so let's see at each state. Oh my God, people stop! I need to turn off my or turn on to not disturb or something like that. Okay. Yeah. All right. Actually, let me turn that off real quick. Okay. Hopefully, set up game messages. Okay. So now I want to see kind of if it simulate what I'm doing right. So okay. So this is actually a little bit annoying because so what I would normally do is I would just do something like this. set it. But of course, my clever trick of turning them to 0 means that they're now 0 limited. So let me just do the. Let me just change it to some silly thing. I think that should be okay. I don't think I use anyone else. With too many Python /Go and other languages, always forget. Standard output. So after one string, so all the R's were deleting all the D's. Man, it's like there's some kind of vote suppression thing going, I guess. Code mimics life. But okay, so what do I do? So I'm just looking at my code, kind of work through it. For every R, so this should be 3, right? Oh, I see. So these signs should go the same way to kind of yeah. So now, as you can see, then I mean, well, let me edit the code. I mean, this test code, and that should be okay now. Don't know why it doesn't print this out. I guess. What? That's actually curious. Why it doesn't print the output out? Did I change something? Huh. Oh, because of this stuff, I guess. That's why. Because the first characters probably got voted out. I mean, the code still works because it just assumes anything that's not RND, and as you can see here, it correctly projects that out. Yeah, okay. Now I feel a little bit more confidence. I'm going to just submit it. YOLO. Okay, accepted. Whew. Okay, that was it is faster than 100%, but less than 100% of it. Oh, wait, 100% is good. I thought I was one of those that gets better but worse. Okay, so that was a pretty tricky question. I think the kind of takeaway I would do is, really analyzing your what you're doing and what's next. I mean, I think to be frank, this could be a much easier simulation problem. But as to point out, if this part of the loop is n square, which I already think even if you have only one round, n square is already too slow. But so I did have to do some work, and it led to some typing. And as I said, this was actually a little bit worrisome, even just in general, because there's a lot of potential for typos, as point out, and like some minor logical errors. And as you can kind of tell, like once we realized that these are the same, we could actually refactor this out a little bit. But I'm going to just leave it like this because I don't know, that's one of those exercises will be left at home kind of thing. All right, so this one actually took way too long. Unhappy with how long it took me, but we got it right on the first try. So sometimes that's all you can ask for. Okay, we'll go on to the next problem.